Next up, we have Riya Karumanchi. She is the founder and CEO of Smart Cane, which is building AI-enabled walking canes for the blind, which she has won several awards and prizes for. Last week, she spoke in front of 20,000 people at the We Day in Toronto. And she was given the award by the Premier of a Leading Woman in Ontario. Today, she'll be speaking about generative design and its intersection with deep learning. And by the way, she's 15 years old. Let's give a hand for Riya.
Thank you. Thanks so much, Lauren. So raise your hand here if you've ever heard of the Marshmallow Challenge. So for those of you who don't know what it is, basically you're given 20 strings of spaghetti, a yard of tape, and a yard of string, and then a marshmallow that you have to put on top of a structure. And the objective of the challenge is in 18 minutes, you have to build the tallest standing structure possible. And I actually had the privilege of being able to collaborate with some of my friends and participate in this challenge about 2 years ago. And I thought it was something really cool. In the end, we were actually able to build a structure that was 36 inches tall while using the least amount of materials possible. So using only what we need and instead not using what we want. And this kind of got me thinking about something called deep learning and generative design. So I was thinking, okay, so if we're able to do that, then shouldn't we be able to apply that into the real world? Because right now in society, we are wasting a ton. We have a finite amount of resources available to us, yet humans are still using up to 55 million tons a year. We need to make sure to conserve our resources, and I think generative design is going to be the future. So I want you to imagine, what if we could solve the housing crisis? Because we only have a certain amount of space of land that's habitable. And right now, we're not using it to its optimal level. Or what if we can create drugs that can solve some of the world's biggest problems in healthcare with a computer instead of a human? And I think this is absolutely insane. So how exactly can we do this? This is how we can do it with deep learning and generative design. And this is something that I started focusing on a few months ago and went really deep on. So I want you to take a look at this chair, for example. We don't really need all of it. Let's take a look at the parts that we really do need. Obviously, the legs that support the structure, the back, and then where we sit. So if we take that all away, this is kind of what we end up with. This is actually 5 times less in materials that we're using. But the beauty isn't creating something that weighs less or uses the less materials. It's being able to input what exactly with an abstract idea you want in a computer, and the computer actually being able to create something for you. So instead, not just one chair, but hundreds and thousands of models of different things that a computer itself thought of using its own creativity. And I think this is absolutely insane. Going from something that's so thick, using an excess amount of resources that we don't need, to ensuring that every single atom is used for a purpose. So instead of a human actually with having no idea of the actual physics and elements of what makes something work and making a design just out of the blue, we're actually able to input an abstract idea of something that a person thinks that they want, and a computer being able to interpret that and actually create something out of it. And not just something that's underperformance of what a human can, something that's far beyond human could have ever imagined. So in order to understand generative design better, it's very important to understand the fundamental aspects of how it works. And this is a basic model of the overview of generative design. So basically, what a designer does is they input an abstract idea of what they want and set up some starting parameters. So let's say I want it to weigh X, Y, Z, and I want it to have this certain material and withstand a lot of exterior forces. And after that, the computer then interprets that and is able to create a lot of different models, but not only that, be able to learn from the different models that it created to make something even better. So first, you start off with the design measures, and then go into actually creating new things, and then the optimization and learning aspects. So let's take a look at the design measures and parameters of actually inputting what a human wants. So current design models, however, are not composed of differentiable functions. So when we're inserting our parametric models, what we want is something that can be able to differentiate one model from another and what makes something better. However, these models aren't able to do that. Instead, we want something that's easily differentiable, but also we want the computer to be able to understand how to create a better version of something without having a direct understanding of how exactly it works in the first place. And we can actually do that with something called Metaheuristic Algorithms. And these actually have a more top-down approach to learning how something works. So let's say I wanted to learn how to play volleyball. I don't have to actually read through a textbook to understand what are the different rules in doing that. I can actually go and learn by doing. And that's what these Metaheuristic algorithms do. So I want you to take a look at this car chassis to put it into perspective. It's really difficult to input into the computer how exactly all the components of a car work. And instead, it can actually run a lot of simulations and tests to understand how it works from a higher level. So the main reason why these metaheuristic algorithms are better than neural nets is because they are composed of differentiable functions that can help you determine why exactly something is better than another, but also think of it as a neural net being able to think inside the box and abiding to the parameters that you just inserted. However, a metaheuristic algorithm can go even beyond that. It doesn't just restrict to the algorithms and parameters that you put in. It goes beyond that to create something that you couldn't even imagine before, and that performs at a very higher accuracy than you thought of. So I want you to take a look at this box model, for example. Let's say I wanted to build the box with the largest volume possible. So what I would do is I would insert my starting dimensions within the parameters of the generative design algorithm. But this algorithm has no understanding of how my parameters actually correlate with the top goal in general of creating the largest volume possible. So what it does instead is it runs a lot of simulations and records the volume of each box it creates. And based on that, it can create a mental model and identify what exact areas can be improved to optimize it as a whole. And take a look at the static model as well. This is called an FEA. And they also use something called defined parametrics that can determine what areas of an object have the highest stress concentration possible and how it interacts with its external environment. So metaheuristic algorithms serving the purpose of understanding how the internal workings of something work and optimizing that, while these algorithms being able to understand how it can withstand, let's say, wind or other forces that may be interacting with it. And the coolest part of generative design that I think is actually a computer being able to create so many different things. And this can actually be done with higher order functions. And higher order functions, basically what they do is they accept a starting parameter as a function and then compute it as results. So I'm throwing a lot of words at you. Let's take a look at an example so we can get a better understanding of this. Let's say I wanted to build a bike and use the least amount of materials in the bike as possible, but also making sure that we have the most effective solution. Without a higher order function, I would actually have to put every single part of the bike into the generative design algorithm to find the most optimal solution for each one, and then later I'd end up with a bunch of different parts that don't even fit together. So what higher order functions would allow us to do is computing the parametrics that we put in to all of the parts as a whole, to not only find the most optimal solution for each part, but the most optimal solution so that each part can work together effectively. And this can be done through a typical summation. Firstly, with the part before the equal sign accepting a function, with the one after computing that to every single element in the space. And going back to the typical summation, the first part would accept the function as an argument, and the next would be the formal definition of the operation. So I actually created a quick demo of some of the generative art algorithms that I used. And I'm not sure if it'll play now, but basically what I did was I used these generative design algorithms to create a lot of generative art. So I inputted an online library of different examples, and it was actually able to create animated art through the things that I've created, all on its own. And through this, it kind of got me thinking about what if we can do that for 3D objects itself? And that's going to be a lot of my next steps within this space too. And one of the coolest parts of generative design is actually the optimization and learning aspects. Being able to learn from previous things that you've created and coming up with something even better. And this can actually be done with something called LSTMs. So LSTMs are also called long short-term memory. And you can integrate this within the Metaheuristic Algorithms. And they're basically composed of 3 main things: an input gate, an internal state, which is also known as the forget gate, and also the output gate and learning aspects. So this is a basic cell model of how the LSTMs would work. So with the 3 main parts, the input gate would collect the previous cell output and the current input, and then squash it between the numbers -1 and 1. And then it uses a tanh function to do that. And then let's take that information to the forget gate. The forget gate would basically take that information and determine what things to keep and what things to forget after determining what inputs need to be turned on and off. So let's say 0 would be forget all the information that it learned, and 0.7 would be to remember 70% of it. And it can then take that information to the output gate, which forms a similar function as the input gate, but later takes it to the next cell, and you find out eventually what things you need to remember to create an even better model moving forward. There are so many applications for generative design, and it's going to impact an immense amount of industries. And one of the coolest things that I'm really excited about is space exploration. One of the biggest problems in space exploration is that we're using more fuel than ever before. And because of this fuel and because of the weight of a vehicle that we release into space, it takes up a large amount of money, and the expenses are massive. So what if we can use generative design to actually reduce the space, reduce the weight, and make sure that every single atom in a vehicle that we release into space is made for a purpose? Imagine how much money that we could be saving that can later be allocated into more projects in the future. And also going back to waste management. There's a lot of problems right now that we're facing, and the world is not tackling all of them, especially when it comes to consuming our resources. We need to make sure that moving forward, everything that we consume is meant for a purpose and nothing is being wasted. And generative design is going to play a pivotal role in doing so. And similar, aviation. So what if we can apply the same thing, kind of like space exploration, but to aerospace industries, to reduce the amount of fuels and be able to allocate extra resources to different things that'll add more value for humans? And something that I'm really excited about is how architecture would be impacted by generative design. So actually being able to see how buildings would be in the future because of this great technology. And I think it would be really interesting just looking around you. And take a look in this theater. Imagine every single atom around you was meant for a purpose. And no atom was wasted. And I just think this is incredible. But I don't think generative design is just limited to material science. What if it can be applied to a lot of spaces in healthcare? What if a scientist could input a certain amount of things and what kind of things that we want a drug to perform and what kind of disease we want it to solve, and teach it through a library of how different chemical reactions interrelate with one another. And later, a generative design algorithm can run multiple different simulations and find out what drug would perform at the most optimal level. And we can even use this for maybe precision medicine, for finding out what drug would work best for a person that would be affected by that. And I think this is incredible. To not only improve drugs and create something that a human could have never even thought of, but creating drugs that were specific to each person. So throughout this whole presentation, I think there's 3 main takeaways that need to be remembered throughout generative design. One being, current design processes are so inefficient, and we really need to solve this. But how do we do that? We need a lot more smart people working on something like this, because the impacts of this could be massive. And thirdly, generative design will disrupt so many different industries, not limited to all of the things that I told you before. And I'm really excited to see the future of this. Generative design is going to have an incredible impact on our world around us, But it's really important that we have more people working on it, and I'm really excited to go deeper into it as well. It's going to be the future, so let's start creating it now. Thank you.
Thank you. Awesome. So for Riya as well, do we have a question from the audience? Yeah.
Yeah, for sure. I'd love to connect with you, perhaps on LinkedIn. And I'm actually working on some things with Autodesk in terms of generative design, and they're very advanced in the field as well. And they've actually released a lot of commercial products in terms of that. So I'd love to see how we could potentially collaborate and look at how this can impact Maple Leaf Foods.